In this lesson, we're going to be looking at tangents, secants, and equations of circles. This is MT10, LT6, and 7. Um, do the first 5 questions, then we'll go over them in class or just to get your knowledge ready for the rest of the lesson. I want you to use relationships between tangents and secants to solve problems. And if you haven't figured out, one of the vocabulary words from this lesson is secant. And we're going to derive the equation of a circle using the Pythagorean theorem. And we're going to complete the square to find the center and the radius. Completing the square is something you did in Algebra 1. We're going to review that again. First off, secant. Secant comes the word from a secar, which means to cut. So in other words, it's a line that cuts through a circle. Notice secant contains a chord, but the secant is the entire line, so it goes through the circle. Now, because we have secants, we have some general rules that go with the angles. And more specifically, it's where the vertex of the angle is. First off, if I have a circle and I have 2 secants, or 2 chords in this case, and they intersect inside the circle, what happens to find this angle here, notice I've got vertical angles, don't I? Because they're going to be the same. And they intersect, or they subtend, 2 of my arcs. I think I'll label those so we can understand what we're talking about. So let's go A, B, C, and D. Since we have 2 of the arcs, X is the average of both the arcs it intercepts. So in other words, it'll be the measure of arc BC plus the measure of arc AD. We're going to divide that by 2. And then if you have 2 secants and they intersect outside the circle, notice, call this X here again, I've got a big arc, I've got a little arc. Outside we subtract. So X is going to be 1/2 the big minus the little. Sometimes I like to write it as big minus little divided by 2. Those are our 2 rules. We're going to talk about a third rule as we do the problems, but it's pretty much the same things we did yesterday. So if I look at example 1, and it's supposed to find X, notice I can't find X. I don't know those arcs. I don't know arc MN. So what do? If you don't know what to do what you can do. Notice I can find, let's call this Y. I can find angle NKQ. Y is going to be the average of 55 and 75. So 55 plus 75, well, that's 130. We'll divide that by 2, and we'll get 65 degrees. So Y is 65. Now that I know Y, I can find X, because notice I got a linear pair. So then X is 180 minus 65, which is 115. Now, on example 2, notice what happens. This is one I didn't talk about in our theorem because I think it's the same thing. Notice my vertex of my angle is on the circle. And angle J, let me try that again. Angle KJH is 116. That's going to be half of my arc. So in other words, because it's on the circle, it's kind of like an inscribed angle. It's half the arc. So in other words, 116 equals the measure of arc JLK divided by 2. So all I do is I multiply by 2 to both sides. And the measure of arc JLK is going to be 232 degrees.